contains a duplicate 3. And it's very easy to understand by the question. So for the index I not equal to j, and absolute of I minus j should be less than or equal to index different. And also the absolute of nums I minus nums j should less than or equal to value different. Yeah, let's just analyze one example. So for the first example, we can choose 0 and 3. So for this one, 1. So the index of 0, the value is 1. Index 3, the value is 1. Yeah, so the value difference is 0, and index difference is also 3. So it meets the conditions we're going to return true. Yeah, we should know it should be less than or equal to index value, index different. And this value different is also less than or equal to. Yeah, this is why let me check my submissions. I make also a lot of mistakes because I didn't read the questions carefully. So let me analyze the first mistake. Yeah, so for this one, I decided to use a sliding window. I decided to use a L pointer from 0 and then try to use R and enumerate the nums. I use a sliding window to check if it is more than the index difference, the left pointer should plus 1. But for this one, actually, for the index value, but the index difference is the absolute of I and j should be less than or equal to index different. But for I, when I solving it, I consider it should be equal. I cannot find the less conditions. So this is why it cannot pass. Yeah, you can see from here. And I also make other mistakes. Yeah, this is still, I used this one to check. It always mistakes. And then I think, if I cannot use like that, why not use other method? Maybe I can solve it. Yeah, because I've already practiced several sorted list problem. Maybe I can use a sorted list to solve the problem. Because for sorted list, I just need to find the first number, and then I need to use the index as a range. So for example, the index difference is 3. I choose the first number 1, and then I'm gonna choose 2, 3, and 1. Because the index difference is 3, it can be 1, 2, or 3. So inside 2, 3, and 1, why not I use a binary search to find a number? Why I can't use a binary search? Because if I don't use a binary search, it will be O(n) squared time complexity. Because inside I have to check one by one to check the number if it meets the condition of value difference equal to 0. Yeah, so if it is sorted like 1, 2, and 3, what's gonna happen? I can use a binary search to find that one immediately. So that will be n log n time. So in this way, I can solve the problem. Let's check the n. N is 10 to the power of 5, so I can solve it. Yeah. Now let me analyze a little bit about it and then go to the code editor to finish the coding. So just for this example, for the first value 1, I'm gonna put 2, 3, and 1 inside my container, inside a sorted container. In Python, I can use a sorted list. So inside the sorted container, this 2, 3, 1 gonna become 1, 2, and 3. Now, I'm sure inside the container, it has already met the conditions of index difference less than or equal to 3. Yeah, because this 1, 2, and 3 meet the condition. I just need to check the value difference inside the container, inside the sorted list. So if I can find this one, so I'm gonna use a bisect left or bisect right. But for me, I prefer to use a bisect right. You can also try to use a bisect left. But I think bisect right is easier for me to analyze. Basically, bisect, for example, for this one, it is a 1. If I use a bisect right, so which position I gonna insert? So this one is at index 0. So for the position, I have to insert at index 1. So this is index 0, 1, and 2. So this means, I can insert at a position at index 1. And the value here is 2. So 2 minus 1, it is 1. It is more than the value difference. But there is another number 1. 1 minus 1, it is 0. So it is meet the conditions, so I can return true. Why? Because the array has already been sorted. I just need to check two numbers 1 and 2 if I use the bisect right. Because for this number 3, and after that, it will always be bigger. It cannot meet the conditions of absolute of value difference is 0. Yeah, because it will be bigger and bigger. Only this one, it may meet the condition, but 2 minus 1 is 1, it didn't meet. But this number before it, it can meet the condition or not. Yeah, it is 1, it meets the condition. But every value just before this one, if there are any other values like minus 1, minus 2, or other values, it must not meet the condition because 1 and 2 is the closest point. So this is why I can use the binary search bisect right to solve the problem. Yeah, so for analyzing the bisect right, we have to check if the index is out of the range. What I gonna do? I just need to check with my number 1 compare with this 3. So if index is 0, I just need to check my number 1 with the first index. Yeah, index it is 1. If the index is in between 0 and less of the sorted list, I just need to check two positions. The nums, if the index is j, nums j and nums j minus 1. If either of them meet the conditions, I can return true. Yeah, I hope you understand the analyzing of this problem. And now, let me code it up from the code editor. So as I explained, we're gonna use the sorted list from the sorted containers to solve the problem. So we can import it from the sorted containers. Import sorted list. Yeah, and by the way, while you are using the sorted list, if you are using the bisect left or right, you should also use it from the library. I mean, you can even there is in bisect module, there's also bisect left or right, but that will be much slower. Yeah, so you have to use the library from the sorted list. Inside of the sorted list, there is also bisect left or right. Yeah. Now let's just use the sorted list. So SL should equal to the sorted list. And inside, how much values we need to choose? So the first value is 1. And we must choose the values after this one. So inside, it's going to be nums starting from 1 to which value? Yeah, because the index difference is 3. So this 1 should plus the index diff. Yeah, so this means if I choose 1, inside my container will be 2, 3, and 1. That's just to check. First, it is 1, and 1 plus 3, it is 4. So 1, 2, 3, it is 4. 4 is not included, so it means it is right. Yeah. For the initialization of the sorted list, now we can check the numbers one by one. So let's prepare index j because I will use the index I for the bisect right. So I'm gonna use the index j first. So for j in range, now I'm gonna start from the second value. It is the index 1 because let me check. Yeah, I have to start from the first index, not the second. Yeah, because I'm gonna enumerate value one by one to check with the containers. This container start with 1, but for my value, I just needed to start it from 0. Now I can use my index I. I'm gonna use as I explained, I'm gonna use from the sorted list sl dot bisect right. I'm gonna search these numbers. So my numbers is nums j. So currently j equal to 0 and nums j is 1. Yeah, I'm gonna search 1 from 1, 2, 3. So this 2, 3, 1 becomes 1, 2, 3. I'm gonna search it from So I'm gonna search it from 1, 2, and 3 to search a value if it is in between. Yeah, if it is I'm gonna search this value inside 1, 2, 3. If I can find a value which the absolute difference is 0, so I can return a true. Yeah. Now I need some conditions to check. So if this I, because I used bisect right, it may out of the range. So I have to check if it is goes out of the range. So this is one condition. And the second condition may be if this I equal to 0. And yeah, the last condition may be just in between. So 0 to the less than I to the less than. Yeah, you can also use some other method. Maybe you don't need so many checks. Yeah, you can make like one line, but it is too long. And even you can put it in one line, make it shorter. Maybe you need to use more time to check the conditions. To check the bisect left, it is inside the boundary, or if it is out, and how to compare with its numbers. So I basically prepared the 3 conditions. Yeah, so if this index equal to length of the sorted list, it means out of the range. It means this number may be a 4. Yeah, inside the number j may be a 4. It goes out of the range. Yeah, and this 0 means this number maybe let's say maybe it is a 0. I'm gonna search 0, so I didn't find it. So where I should insert, I will insert from the 0 positions. Yeah, so if the numbers is 1, so it is in between. Yeah, I'm gonna search this 1, so I'm gonna search it from here, from this position. Yeah, if you understand the 3 conditions, basically we can check. If it meets either of the 3 conditions, we're gonna return true. Otherwise, we're gonna return false. Now let's check the first condition. So if this I equal to the length of my sorted list, and I also need to check the value. Now, my value should always be bigger than this number 3. Yeah, now I need to check. And my number is, let's say, it is nums. Yeah, because currently it goes out of the range, but I can use nums j as my number. Maybe my nums j is 4, so nums j minus the last number inside my sorted list. So it is SL minus 1, and it should be less than and equal to the value difference. Yeah. So this is one condition. I can return true. So the second condition is if this I is 0. Yeah, if I equal to 0, maybe my searched number is nums j is 0. Yeah, so let me put it here. If my nums j is 0, normally I would insert it in the first positions. Yeah, so I have to check if this I equal to 0, so my nums j would be smaller. Yeah, and which number is bigger? So nums SL0 should be bigger, and minus nums j should be less than and equal to the value difference. So I can return true. Now let's just finish the third conditions. Actually, for the third condition, it is not so difficult. Let's just put it inside. Yeah, if it is in between, and there will be 2 situations. So we're gonna first, for example, I'm gonna check this nums. For the first value, it is 1. I'm gonna search this 1. So for searching this 1, normally it's gonna insert into the index 1. Yeah. So the first condition, let's say, so the nums j would be bigger. Yeah, because the nums j is 1. Nums j should be bigger than the number before it. Yeah, nums j should minus SL. Yeah, because basically I would to insert this j. Insert the position should be at index. At index I. So this one nums j should minus SL index I minus 1, because I minus 1, it is this 1. Yeah, so it should be less than and equal to the value difference. Or my next number, it should be SLI. So SLI is number 2. Yeah, 2 minus my value nums j should be less than and equal to the value difference. Yeah, maybe you can think easy way to find all the conditions. Maybe you can use bisect left or right. Basically, I think it's the same. Yeah. For me, I just need to find 3 conditions to check which is true. Otherwise, I'm gonna return a false. But this is not the end of. We have to, use it like a sliding window for the sorted container, because this is 1. Currently, our value is here. But for the next loop, while my index j goes to number 2, what's gonna happen? Inside the containers, first of all, I need to remove this number. So this means my sorted containers need to remove this number. SL dot remove this number is nums, let's say j plus 1. Yeah, because this number is after it. But we need also to add one number after this 1. Currently, we don't have. So if there's another number, maybe 4 or 0, we need to add this number. Yeah. But before that, we have to check the conditions. So for here, we use the less of nums as our boundary. Actually, we can make it less of nums minus 1. Yeah, because I not equal to j, this means the index difference will be at least 1. Yeah. So from here, we're gonna keep it safe. Just make it less of nums minus 1. Because for the I and j index, the index difference should be at least 1, should be less than or equal to 1 at least. Yeah, because I not equal to j. So here we can use a nums len nums minus 1. And now from here we need to add the numbers. So which number we need to add? So SL, we can, here we use the remove, and now we can use the sorted list to add a number. Yeah, so the number plus 1 and plus the index diff. Why? So for example, currently my index my index is 0. My container is 2, 3, and 1. Yeah. Now if I go to 2, it means this 2 from the container has been removed, but I need to add another number. Yeah. So the index is j plus 1, it is 1. So if I need to add another number, I need to plus the index and difference. So it will be 2, 3, and 4. So it means j plus 1, currently it is at 1. I need to plus an index difference. Now I can add another number. Yeah, but before I add this number, I have to check. So it must be inside my boundary. Yeah. So if it is less than the, let me put it like this, then the length of nums, I can just put it inside. This is basically the entire code. Yeah, let me check if I make any mistakes and if I can debug. Sorted containers. From sorted containers, import sorted list. Yeah, because inside sorted containers, basically there are sorted list, there are also sorted set and sorted dict. So that is why we call it sorted containers. It is a plural because it is not one sorted list. You can also use a sorted set and sorted dict to solve other problems. Yeah, but most often used is the sorted list. And inside the sorted list, most often used is bisect left or right, and sorted list dot remove or add. Yeah, as you can see, it's similar like a sliding window, and also you use the boundary search. That is why this problem is a little bit harder. Yeah, I just run it. It seems to work. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it works and it passed all the testing cases. Yeah, and this is just an example of some of the hard problems that can be solved easily by using the library. For Python, we have a sorted list. For some other languages, yeah, maybe you have ordered set or sorted map. Yeah. So for the different languages, you can use their library to solve the problem. Otherwise, if you don't use libraries, it's going to be very difficult. You have to prepare your library, like the segment tree or binary index tree, to solve the similar problems. But for this problem, it's easier to think by using the ordered set, by using the sorted list. Thank you for watching. See you next time.